Welcome to problem of the day 192. Got a triangular distributed load of 7 kips per foot and then 5 feet total. So we're going to try to find the reaction forces in A and B. So what I do first is find the resultant force of the triangle here, and it's applied 1/3 from the end. So 35 kips came from 7 times 5, and then you divide it by 2 because the area of a triangle formula is base times height times 1/2. So you get 17.5 kips. So then that's applied at 1/3 from the end here, so 1.665 from the end, or 2/3 from the other end, which is 3.335 there. And it's the more force is at the bigger part of the triangle, so that's how you determine which side the force is applied closer to. So the bigger side is closer, so that's the 1/3 from the end there. And then we draw a free body diagram here, and then you can sum the forces in the x, which equals 0. And then we're actually going to apply our equations now. I would sum the moments at A because that's the pin support, and then you end up getting negative 17.5 times 3.33 because it's that distance, that lever arm from here. So you'd be like that's the lever to create a moment, and it's negative because it's going clockwise, and then counterclockwise force of By times 5. So that's this lever arm going that way. And then what you end up doing is solving for By, and you get By equals 11.655 kips. And then you can sum the forces in the y, so you get sum the force in the y equals 0 equals negative 17.5 kips plus the By force that we found, which is 11.65 kips, plus Ay, and then you solve for Ay, and Ay equals 5.85 kips. I hope that helps.